Good morning. Thought I'd go ahead and knock out our car talk for the day. I'm just going to go over the operation and diagnosis of VVT. In some vehicles, it's also known as CVVT or DCVVT. VVT stands for variable valve timing. CVVT is continuous variable valve timing. Then you have dual continuous variable valve timing. Different companies call it different things. Honda calls it variable cam timing, which is the same thing, just different way of saying it. So basically, you've got your 4 parts of the combustion cycle. The easiest way to remember it, and it sounds a little crude, is suck, squeeze, bang, blow. If you got an engine that will do that, it will run. The purpose of variable valve timing is to increase the efficiency in which your engine can do that, and that's the game in the automotive world, is efficiency. How efficient can you ignite a fuel-air combination? Variable valve timing. So back in the day, when everyone had the timing lights and all that stuff, if you wanted to hop up your engine a little bit, make it run, a little meaner, or take it down because you got too much fuel or whatever, you'd have to manually set the timing. You'd use a timing light and you would change the position of the timing. Generally done at the distributor. Cars don't use distributors anymore. And so the ECM, your engine control module, can take a look at how the engine's performing, and then based on what the throttle command is, what the load is on the engine, can determine whether it should advance or retard the timing of that engine to run more efficiently. And that's where VVT comes into place. You've basically got your oil passages on your cam journals, and the forward one has got passages that allow oil to flow from the cam journal to a VVT actuator at the end of the camshaft. And so instead of just having a basic cam sprocket, you've got a sprocket with a actuator on it that is driven by oil pressure. And now this is the most common way that I'm talking about. I'm talking in general common manner. A lot of companies are going to electromagnetic controlled, which is pretty interesting. I left working at dealerships and stuff like that when they first started coming out with that. So I don't have a lot of hands-on experience with the electromagnetic actuation of VVT. I think Mercedes and BMW, I think those guys have been doing it for a while. Hyundai just started it, I think like 2 years ago, 3 years ago, something like that. So I'm talking about the hydraulic driven. And so some of the main components is you've got an oil control valve, or a VVT solenoid, depending on the manufacturer. And its job is to open and close to control the amount of hydraulic pressure via engine oil is sent to the VVT actuator. VVT actuator's got a couple channels in there. And as pressure is increased, the pressure applies against these channels, and obviously it's going to force, the purpose is to force something to move, and so as pressure increases in these chambers, they try to spread apart from each other, and it causes the actuator to rotate, and it moves the timing. So the chain is on this, and it'll change the timing of the engine. or the oil control valve can close, slowing down or stopping flow to the actuator. And there's this big old coil spring in there, and it allows it to rotate back because there's no opposing force. And that also will change the timing of the engine. And so what this does is, in your combustion cycle, you're not, and I pick on a guy at work all the time because he's like, oh, so you mean it speeds up or slows down the engine? No, it's not what it does. RPMs, RPMs don't matter concerning the operation of the VVT. It just changes when things happen, but it doesn't change the speed of the engine. And so you can make, your valves open sooner, you can make them open later, depending on what you need. And then you got other companies that got fancy. Some of them have been fancy for a while. When I say fancy, I mean they went beyond that. They went beyond timing just the valves. They developed engineering that will not only adjust valve timing, but adjust valve lift. Like VTEC, Honda's VTEC. It's a crude, easy, simple, low failure design that allows them to control valve lift. And why do I describe it like that? Because companies like Mini and BMW and the Germans have got to over-engineer everything. So they've got something similar. It's an eccentric shaft with a worm gear on a motor with a separate bar, and it can adjust valve lift as well. So uniquely that if you know what you're doing, you can actually run some BMW engines without a throttle body. You could use the eccentric shaft system in place of a throttle body. I've actually seen demonstrations of it. It's good technology, but the design of it has poor failure rate. At least in my experience. The gears like to chew each other out, and you get, journal wear just like, you would see on a cam. Anyway, so engine makes a command. The oil control valve either opens or closes, and then pressure either increases or decreases in the actuator. The timing of the engine is changed based on what the ECM wants. So let's say you got to check engine light, and so your P0011 through like P0016, I think it is all your timing correlation codes. And what a correlation code means is the ECM detects that the correlation between the crankshaft and the camshaft is outside of tolerance. It's outside of what is allowed or what is possible for the VVT system, for a set period of time, as designated by the manufacturer. So there's a difference. It's you might only have the ability to go 33 degrees, and your engine's running 40 degrees. Well, something in the correlation between the crankshaft and the camshaft is wrong. So how do you diagnose that? What do you do when you get an intake cam over advanced or a exhaust cam over advanced? And so I'm going to walk you through just some brief steps of how I like to diagnose those things. The first thing I do, and when I have these talks, what I'm talking about diagnosing the problem after it's verified. I mean, obviously, if you work in a dealership, you work in a garage, there are steps before this that are just good practice. You want to verify the customer complaint. After you verify the customer complaint, you want to make sure that there's no TSBs, There's no recalls. You want to be well informed going into a diagnosis, going into diagnosis labor when you're actually putting your hands on stuff. So we got an intake cam over advanced code. We want to diagnose it. Generally, what I like to do from here is I like to look up the spec on the oil control valve. I like to know circuit specs. So, generally speaking, on oil mount, the oil control valve. I don't know about other manufacturers, but I know for Hyundai has a temperature range. So, if the OCV is 60 degrees, you'll get this kind of ohm, but if it's engine temperature, if it's 100 and something degrees or whatever, it's this is the spec ohm. And so what I like to do is just ohm it out. And you can ohm them out in the engine. If they're easily accessible, which a lot of them are, you just pull one, you unplug them, you pull one bolt, and it slides right out. I like to ohm them out outside of the engine. And the reason I do that is so that I can take a look at the screens. I'm looking for sludge. I'm looking for metal debris. If the screen's got some sludge in it, it's obviously going to restrict flow. Same thing with metal debris. It will restrict flow. And obviously the VVT actuator is not going to do what it's commanded to do because it's not getting the right amount of fluid or oil that it's supposed to be getting. So if you got sludge, you can try cleaning it. Recommend servicing the customer's engine, and then continue diagnosis from there. So let's say we pull our oil control valve, ohms out correctly. It's a solenoid, is what it is, and just like in automatic transmissions, anytime you got a solenoid that constantly moves, that is constantly being commanded, you're going to eventually wear the bore. Maintaining your vehicle on a regular basis will prolong this, because the viscosity of your engine, or the engine oil, by changing your oil regularly, will keep everything well lubricated, and it will be less of a problem. So, maintenance your engine. But let's say ohms out good, no sludge, no metal debris, nothing like that. So we know the oil control valve is not the problem. So stick it back in there, bolt it back up, and then the next best thing that I would like to do is get a scan tool, hook it up to the car, and you can go in and command a timing change. So I'm going to tell it, hey, I want you to advance the timing. And if you tell it to advance for so many degrees, there's a spec that you should be within. So the engine will attempt to advance itself, and then you're supposed to be within so much of what you command. And if it can't do it, if it can't get there, then you might have an actuator problem. Ford's notorious for it. Sometimes you got all kinds of different things that can happen here. And so that's why the next step is to get permission to remove the timing cover and visually inspect the components. You want to run the command test first. The reason being is because if you look at everything and everything looks good, then your problem's the actuator. Because you can't really look inside one of those. You can. They can be taken apart, but people don't like to. I don't like to. It's just not common practice. It's got a big old spring in there. So sometimes that spring will break or dislodge, can cause problems. The pins that hold it together can wear and oblong the holes. Those pins can break. You've got a guide that comes off the camshaft that'll slide into a hole on the back of the actuator. That can wear. That hole can oblong. That can break. It's normally really bad news when that breaks. And so forth and so forth. You also want to keep a mind on your cam lobes. If cam lobes have significant wear, it can throw an VVT code. And so when you go in and inspect it, obviously you're looking for wear on your timing guides. You're looking for wear on your timing chain. And just kind of a pet peeve. A lot of people say, oh, well, your timing chain is stretched. Well, timing chains don't stretch. They don't stretch. You can stretch metal, but not under the conditions present in an engine. The pins that hold the links together will oblong the holes through wear, and the links will wear. And if enough links wear, well, then you're going to have a problem. I mean, even if it's, 1,000. If each link is 1/1000th, then overall you're going to have some extra chain length. But the chain metal itself does not stretch. Anyway, so you want to look for wear. In the chain, you want to look for wear in your guides. Broken guides are often the cause of codes. It's very important to know what the manufacturer expects for testing on the tensioner. Generally speaking, manufacturers like you to measure tensioner stick out. So with timing components installed, they want you to measure the length that the piston is coming out of the tensioner. And once you measure that, that'll give you an idea. If it's fully extended, then it's either blown out or there's too much length or excessive wear to the chain, allowing it to fully extend, and it is still not tight enough. I would recommend all the timing components: new chains, guides, tensioners. I don't like to reuse tensioners unless everything looks super copacetic. Just preventive measures. And if you're doing VVT actuators, say you get in there and everything looks good, so you want to do VVT actuators, and the car's got 100,000 miles on it, or it's got 150,000 or so forth, I'd probably go ahead and recommend timing chain and guides and tensioners anyway to the customer. Just, hey, I'm here. You're not paying double for the labor. Extra $100 to $200, and you get all new timing components. Because I got to take the chain off anyway. Some cars you don't. Some cars you can just lay the actuator forward, keep the chain above the timing cover. Anyway, so that's our steps of diagnosis for VVT. Real short summary-ish way. Check your oil control valve. If oil control valve is good, remember we're gonna ohm out the oil control valve, and then we're gonna inspect for debris. If everything's good there, we're gonna do an actuation command on the VVT actuator. If it stinks, we suspect that the VVT actuator has failed in some manner. If it's okay, but you still got a code, you still want to visually inspect all the timing components for wear and breaks. Alright, enjoy your day.